Hey, Suhai Earth Science students. This is Mr. McLeod again. Welcome to the next scintillating astronomy podcast. In this series, we will look at our night sky in some detail, focusing on constellations and specific stars and when and where to find them this summer. So get your notes out, some to write with, and let's get started. First, let's clear up a very frustrating point for me that occurred way too often in one of our recent quizzes. Namely, what causes the seasons? Remember, it's the tilt of the Earth and its orbit path around the sun we call revolution that causes the seasons, not any differences in distance. Write that in your notes. Most of you put that it was the tilt and the Earth's rotation that caused the seasons. The rotation of the Earth causes us to have day and night. It's the revolution of the Earth around the sun and the tilt of the Earth that causes the seasons. Now, while the sun's distance from the Earth varies slightly throughout the year, becoming closest about January 3rd, it really has no noticeable effect on the climate. Write that down. In fact, the effect of the sun being closer in the northern winter is actually reduced by the fact that the southern hemisphere has a higher percentage of oceans, and those oceans reflect heat and light back into space more efficiently than do our forested land masses. Also write that in your notes, very important. Now what's really interesting is, what if the Earth's orbit were very elliptical, way more elliptical than ours is, like say Mercury? Well, what would happen then is this effect would be more pronounced. We'd have more pronounced seasons than we even do. So if that orbital path is way stretched out like Mercury's, we'd have even more differences in seasons. Now, what about the opposite? If the Earth's axis were not tilted at all, then the seasons would be produced only by the varying distance of the sun. Write that down. So again, if there were no tilt of the Earth, then the seasons would be produced only by the varying distance of the sun. Make sure you get that in your notes. Now the only difference here, what I mean by here is if the Earth's axis were not tilted, would be that the seasons would occur at the same time for both hemispheres. No tilt, no differences in seasons for the hemispheres. So north and south hemisphere would have summer at the same time. North and south hemisphere would have winter at the same time. Write that down. Now let's look at the last motion of the Earth related to its rotation. Not its revolution, its rotation. This move is called precession, and you can see precession in this diagram here. Precession. Precession. Write that in your notes. Then write that precessional motion of the Earth's axis is a very slow conical motion caused by the combined gravitational pulls of the sun and the moon. So get that in your notes. It's the very slow conical motion, and you can see conical means cone. You can see a conical motion. We'll show a really good example of it here in a second. But there's a cone formed right here, a conical motion now that's formed from the gravity of the sun and the moon. Now let's look at exactly how this looks like in its precessional motion from a video clip. I'll be back in a second. Now remember, we called the motion conical, and in this nice little simulation, you see two cones formed. Now here are the axis of the Earth with the 23-degree tilt. And remember, it's the sun's gravity and the moon's gravity that cause this conical motion. So this does a great job of showing how this, how the axes wobble. They kind of go back and forth. So this is a pretty good example. Here's the another good example of how it looks like, kind of like a top, like a gyroscope. So remember, it's the conical motion caused by the gravity of the Earth and the sun pulling on the Earth, or of the sun and the moon pulling on the Earth. There they give you a pretty good view sideways of what it looks like. Now, what do you think would happen to this precessional motion if the moon weren't there, if it never existed? By the way, great question. Calculations have shown that without the presence of the moon, the 23.5-degree tilt of the Earth's rotation axis would not be maintained. Write that down. And the second thing is that this axis of rotation, this 23.5-degree tilt, would also have wild swings because no moon existed. So the moon stabilizes the Earth's axis at 23.5 degrees. Also write that down. Remember the cone that's formed by this precessional motion. It takes about 26,000 years to draw one of those cones. And you see a yellow circle here that represents the cone that would draw, that the Earth's axis would draw. Now, during the precessional period of about 26,000 years, the Earth's north-south axis traces out a circle in the sky like this yellow oval you see here in this picture. Now, presently, the celestial North Pole points to within a degree of what star? That's right, ladies and gentlemen, Polaris, or the North Star. However, in the year 14,000, it will point roughly toward the star Vega, which we'll show you where it is in the sky soon. Write that down. So presently, the celestial North Pole points to Polaris, but in the year 14,000, it will point toward a star, Vega. So you can see the arrows here draw the path now that precession will take. And here's Vega right here. Here's Vega. So in 14,000 years, our celestial pole will point to that star, while right now it's pointing here at Polaris. Okay, enough Earth rotation stuff for Pete's sake. Let's get on to the constellations. So, how many stars are there in our galaxy? And more importantly, how many stars can we actually see? Astronomers estimate there to be about 200 billion stars in our galaxy, the Milky Way. So write that down. We estimate about 200 billion, or 2 times 10 to the 11th stars in the Milky Way. However, there are only about 6,000 stars that can be seen by the unaided human eye, although only about half at any one time. So write that down. So there's about 6,000 stars that you can see without using anything but your eye, and we can only see about half at any one time. So make sure you write that down. Now, what's really interesting is that about half of these stars that we imagine to be single are actually binary stars. Now, we've mentioned binary stars already in this class. We call them double stars, which are very close together. So write that down. About half of the stars that we imagine to be single are actually binary stars or double stars. Write that down. So without realizing it, we actually see about 9,000 stars. Again, get this in your notes. Remember, we said we can see 6,000, but some of them are double stars. So we can actually see about 9,000 stars. Now let's blow your mind a bit, as if we haven't already. Our galaxy has 200 billion stars, right? And since there are at least, scientists estimate 50 billion galaxies in the visible universe, 50 billion, write that down. So our galaxy has 200 billion stars, and there are about 50 billion galaxies in the visible universe. There should be a total of more than 10 billion trillion, or 10 to the 22nd stars. Write that down. 10 billion trillion, or you may be more familiar with 10 to the 22nd stars total. Also write that although the vast majority can't be seen, even with the most powerful telescopes, the vast majority of those 10 to the 22nd stars cannot be seen even with the most powerful telescopes. Can you imagine why? If you said because they're too far away to see, you're a very, very, very smart, bright, well-taught earth science student. Okay, on to constellations. In popular usage, the term constellation is used to denote a recognizable group of stars. So write that down. The term constellation, in popular terms, is used to denote a recognizable group of stars. However, astronomers have redefined the constellation as 88 regions of the night sky, not any particular star formation. Write that down. Astronomers have redefined the word constellation as 88 regions of the night sky, not any particular star formation. Now, they refer to the groupings or star formations themselves as asterisms, A-S-T-E-R-I-S-M-S, asterisms. Also write that in your notes. So what we may refer to as constellations like Orion right here on the left, scientists refer to, or astronomers refer to, as asterisms. The constellations astronomers refer to are areas of space that you see here on the right. They're areas of space that you see here on the right. So here's Orion. This looks nothing like this constellation here, but Orion is a spot in space that astronomers refer to as constellations. Now, for our purposes, we use the word constellation to describe familiar groups of stars, pardon me, in our night sky. But understand that there is a difference if you're an astronomer. We're going to refer to these as constellations because for all intents and purposes that's what they are, but scientists use the term in a completely different way. Okay, now a word about the zodiac constellations. On its apparent eastward journey around the ecliptic, and you see the ecliptic here now as the sun's path around the Earth's path around the sun. The sun appears to pass through the 12 constellations of the zodiac. Write that down. And I'd also like you to write all 12 zodiac constellations, which you see here. So get that in your notes right now. So on its apparent eastward journey around the ecliptic, the sun appears to pass through the 12 constellations of the zodiac. Now, over 2,000 years ago, when the pseudoscience, pseudo means false, the pseudoscience of astrology, that's where people think they can predict what's going to happen to themselves based on what sign they are. So the pseudoscience of astrology was introduced 2,000 years ago by the famous mathematician Euclid, where a person's astrological sign was determined by where the sun was in the zodiac on his or her birthday. Now, because of the Earth's precessional motion, our birthdays are now one sign later than they were 2,000 years ago. So let's get that in your notes. So 2,000 years ago, Euclid, E-U-C-L-I-D, invented the pseudoscience of astrology. And he said that a person's astrological sign was determined by where the sun was in the zodiac on his or her birthday. Sorry. Now, also write that because the Earth's precessional motion, our birthdays are now one sign later than they were 2,000 years ago. So much for that science, hey? Okay, now that's it for the introduction part of constellations in the night sky. So go grab those questions in Moodle, answer them, and let's move on to part 2. See you soon.